Converting units in the metric system is pretty simple because the only difference between a larger or smaller version of the same unit in the metric system, like grams or milligrams or kilograms, is a factor of 10. If you multiply by 10 or divide by 100 or multiply by 1,000, you can convert between any of those different versions of the same kind of unit. And since multiplying or dividing by some number of tens just moves your decimal place, all you really have to do is scoot your decimal place to the left or right a certain number of spaces, and you can skip the math and still get the correct conversion. Now, that is not the case with a lot of conversions, with especially the US customary system. So, I'm going to show you how to handle any kind of unit conversion, whether it's in or out of the metric system, officially doing it the math way instead of just the shortcut moving your decimal place kind of way. So let's look at this example here. A hippopotamus can drink up to 56 gallons of water in a single day, and we got to convert that into liters instead. Now, that would be nice if a gallon and a liter were the same amount of volume and it was just a different name for the units, like 1 gallon is 1 liter, because then 56 gallons would be 56 liters. Not the case. It would also be nice if this were like the metric system where there'd be a kind of 1 to 10 or 1 to 100 ratio where maybe 10 liters is the same as 1 gallon. And then all we have to do is move the decimal place. But that is also not the case. Okay, the equivalent amount of liters to gallons can be given in something called a conversion factor, which is something you've probably dealt with from day to day with things like 12 inches in a foot. That's a conversion factor. Or 3 feet in a yard. Or 16 ounces in a pound. 60 seconds in a minute. Okay, all of those are just conversion factors of how much of this is the same as how much of that. So we need to figure out a conversion factor for gallons and liters. Now, I have conveniently collected a bunch of conversion factors down here at the bottom, where we have 3.78 liters being equivalent to 1 gallon. Okay, I'm going to come back up here and rewrite that conversion factor so I have it for later. Okay, and before I do that, I'm also going to rewrite my measurement. When doing conversion factor problems like this, it can be really easy to put the right numbers in the wrong places. So first thing I want to do is rewrite the measurement that I need to convert. This number is what's going to change, 56 gallons. And I'm going to write my conversion factor up here somewhere so I don't forget it. 3.78 liters is equal to 1 gallon. Now, because liters and gallons are different numbers for the same amount of volume, like how 1 gallon is the same as 3.78 liters, this number is going to change, as well as my units. So in the end, my answer is going to be totally different looking. So I need to do some math to this to be able to change it into liters. So I'm going to make a little multiplication sign here. I need to multiply it by something that has both these pieces of information, the liters and the gallons part. So, what better way to put two pieces of information in the same problem than to use a fraction? This fraction bar can have one thing on top and one thing on bottom. So maybe it's gallons on top and liters on bottom. Or maybe it's liters on top and gallons on bottom. Okay, if I can figure out which one goes on top and which one goes on the bottom, then I just have to match up the right numbers with the correct units, making sure that the 3.78 sticks around with wherever the liters units goes, and the 1 sticks with the gallons unit. Okay, but how do I figure out what goes on top and which goes on bottom? Well, let's take a second to talk about some math facts here. Okay, like, for example, if I take something like 4 divided by 4, that equals 1. If I take something like 32 divided by 32, that is also 1. Or if I take 100,000 divided by 100,000, that is also equal to 1. You can do this with any two numbers. Anything divided by itself is equal to 1. Now, 1 is a nice number to deal with in math because anything multiplied or divided by 1 stays the same. If I take 83.5 and I multiply by 1, my answer is still 83.5. it's almost like this just goes away, like it wasn't even there in the first place. Okay, same thing happens when I divide by 1. So if I take 0.03375 and I divide by 1, that is equal to 0.03375. The number doesn't change. It's again almost like I could just ignore this part right here, which means if I can multiply or divide by 1, it makes my math a lot more easy. So if I can change something I don't need anymore into a 1, then that will essentially get rid of it in my math. It kind of just vanishes. Doing that is called canceling. Whenever I can get something divided by itself, like 100,000 divided by 100,000, it essentially is canceled and goes away. And technically, it changes into a 1, but when that 1 is multiplied or divided to something else, it essentially vanishes. Okay? Now this works the same way, not just for numbers, but for other things like variables. If you start working on algebra problems, and I have something like a y divided by a y, that also equals 1. You can essentially cancel these out by dividing the same variable by itself. And I can do the same thing for units. Gallons divided by gallons is also 1. It essentially cancels. So, what I need to do is make sure that if I'm trying to get rid of this gallons unit, I want it to cancel out and go away so I can replace it with liters. I need to make sure that the gallons unit I put in the conversion factor is where it's going to get divided. The top of a fraction like this is going to be multiplied. This is called the numerator. The bottom part, called the denominator, is where things get divided. And you've probably seen this before whenever you work out a fraction problem. Like if you are supposed to take 25 divided by 50, you could reduce that down to, say, 1/2. But if you got to plug that into a calculator and get it as a decimal, you take it as 1 divided by 2. Or you could type in 25 divided by 50. But a fraction is really just showing division. It's just another way to show how you divide things out. Same thing here. Whatever's on the bottom is going to be divided. So I want to make sure my gallons unit is down here where it's going to get divided, which means my liters unit has to go up on the top. In doing so, when I multiply by whatever's up here and divide what's on the bottom, my gallons unit is going to go away, and I'll get to keep this liters unit. Now I just have to make sure that the numbers for my conversion factor end up in the right place. So if it's 3.78 liters, being equivalent to 1 gallon, I have to make sure that I put the 3.78 liters up here instead of down here. It's not 3.78 gallons being equal to 1 liter. It's 3.78 liters being equal to 1 gallon. Now this is something I can go plug into a calculator. So if I take 56 times 3.78 divided by 1, I should get my answer. Where, again, dividing by 1 is not really going to change my answer, but I can still plug it into my calculator if I want to make sure I'm not missing anything. So I'm going to take 56 times 3.78 divided by 1, and I get 211.68. Since I took a number of gallons divided by gallons, my gallons units are going to cancel out. My liters units get to hang out. So now my answer is in liters. So 56 gallons is the same as 211.68 liters. Two different numbers because the units describe a different amount of volume. Let's do another example. If a parrot has lived for 18,250 days, how old is the parrot in years? Okay, again, before I do anything, I'm going to rewrite my measurement to know that this is what I have to change. 18,250 days. And I will need to multiply and divide it by a conversion factor that contains both the unit of days and years, where hopefully I get rid of the days unit and I end up keeping the years unit. Okay. Now, in order to figure out what goes on top and what goes on bottom, that just depends on what I'm trying to get rid of. I want the days unit to go away. So I need it to be divided by something that also has the days unit. Whatever's on top here is going to get multiplied. And the other unit I'm trying to relate days to is years. So years is going to be going up here. Now, I just have to put in how many days are in a year or how many years are in a day. And you might know this one off the top of your head. There's about 365 days. There's about 365 days in 1 year. I can erase the S off here if I want to be grammatically correct. So this time, the 1 is on the top instead of on the bottom. Sometimes it's on the top, sometimes it's on the bottom, but what really matters is making sure that your old unit is on the bottom of the fraction bar so it can get canceled out. And your new unit will be on top where it gets to stick around. So if I take 18,250 and multiply by 1, it's still 18,250. If I divide it by 365, that's going to change my answer, and I get 50. 18,250 days is the same as 50 years. Just two different ways of writing that measurement. Okay, let's try a couple harder ones. Let's look at this 6th problem here. A gliding seagull can stay airborne for a quarter of a day. That's 0.25 days. So first things first, I want to figure out how many hours that seagull can remain in the air. And then I want to figure out how many seconds the seagull can remain in the air. So let's start with this first one, where again, first thing I'm going to do, I'm just going to rewrite this 0.25 days to make sure that I don't accidentally put that conversion factor in the wrong place, or that measurement in the wrong place, in the place of the conversion factor. Okay, and that can happen really easily. If you get going on these problems, you're like, all right, I got to get rid of the old unit, so it's going to be on the bottom. I put days down here, so that way, when I do the math of this, I'll multiply by whatever's on the top. I divide by what's on the bottom. When you go to write in the number for this days part, you might see, oh, okay, I've got a number right there. You put the 0.25 here, and now you're going down the wrong track. The only numbers that should go in your conversion factor are how many things are equivalent in those two units. So if I'm changing from days to hours, I'm going to say HR for hours there, then I want to make sure that I'm talking about how many hours are in 1 day or how many days are in 1 hour. So I have to make sure that I use only those numbers. The actual measurement does not touch this conversion factor. Okay? The conversion factor should be totally independent of whatever number you are trying to convert. So regardless of whether I'm talking about a quarter of a day or 16 days, there are 24 hours in 1 day every time. So if I take that and multiply by the top, divide by the bottom, my days units is canceled as it's divided by days. The hours unit sticks around. And the rest I can do in a calculator. So I'm going to take 0.25 multiplied by 24, divided by 1, which the dividing by 1 part doesn't really change my answer. And I get 6 hours. And some of these you can kind of estimate in your head and say, hey, that sounds about right. If this is a quarter of a day or about a fourth of a day, 0.25 days, then it should be quite a bit less than the full 24 hours. Half of a day would be like 12 hours, and half of that for a quarter of a day would be about 6 hours. Okay. However, making sure you have the unit conversion method like this helps us to take care of situations where the numbers are too difficult to just handle in our heads or to verify whether that sounds right or not, especially if we're using units that aren't super familiar to us. Now let's do one more where we want to try and figure out how many seconds the seagull can remain in the air. Now, I definitely don't know how many seconds are in a full day. So if I wanted to try and convert from 0.25 days into seconds, I don't think I have the conversion factor for that. But hours is a lot closer to seconds as a unit than days is to seconds. Like, I can relate hours to minutes and minutes to seconds, so those are closer. So I figure let's save ourselves some time and continue on from this point. Since 6 hours is the same amount of time as 0.25 days, there's nothing wrong with continuing on with this. So if the unit is closer to what I'm trying to change it into, I might as well continue on with this. So let's write down this measurement, 6 hours. I'm going to multiply by a fraction bar. Okay, where I'm going to end up multiplying by the top, the numerator. I'll divide by the bottom, which is the denominator. Okay, and in order to get rid of this hours unit, I need to make sure that I'm dividing by something with the hours unit. 95% of the time in unit conversion problems like these, your old unit is going to go on the bottom. So new unit above, old unit below. So my old unit of hours is going on the bottom. I'm going to shorten that to HR for hours. The top is going to be my new unit, which is seconds. So now I just need to figure out how many seconds are in an hour, which I don't know off the top of my head, but maybe I've got it down here in my conversion factors. I don't see it. I've got how many minutes are in an hour. I've also got minutes and seconds here. So I have a path that I could take to get from hours to seconds, but it's going to take 2 conversions, which is okay. I'm going to split this into 2 conversions. Where even though I don't have a conversion factor that takes me straight from hours to seconds, I can convert from hours to minutes. And then I can do a second conversion from minutes to seconds, which, I mean, is kind of what we're doing here by changing from days to hours and then going from hours to something else. Like it could be seconds if I had the conversion factor, but since I don't, I'm going from hours to minutes next, and then I'll go from minutes to seconds. So to change from hours to minutes, I just need this conversion factor here. There are 60 minutes in an hour, so I want to make sure that I don't do this. Don't put 60 hours in 1 minute. That would be a heck of a minute to experience. So instead, it's 60 minutes in 1 hour. Okay, so if I take 6 multiplied by 60 divided by 1, my old unit of hours is going to cancel out. I get to stick around with minutes. And I take 6 multiplied by 60. And that gives me 360 minutes. Okay. Now I could take this 360 minutes and continue on to do my next step of the problem to get minutes into minutes into seconds. But I'm also going to show you a pro move here that you can do. If you have not converted into the unit that you want yet, you don't actually have to end the problem and get your answer that you don't actually need. I'm going to erase this. Instead of starting a whole nother conversion factor problem with that 360 minutes, I'm just going to make another conversion factor. If I multiply by something here, and I want to try and get rid of the minutes unit now so that I can make way for seconds, now the minutes unit is the old unit, which means it has to go on the bottom of the next fraction bar. It was once the new unit, it is now the old. So I'll end up dividing by this next fraction bar on the bottom and multiplying by the top like usual. And when I do so, the minutes unit is going to go away next. It's going to get canceled out. Okay, which means I can now have room to put my seconds unit in as my new unit. Okay, if you do multiple conversion factors like this, kind of trailing together, then you'll kind of see a pattern of your old unit going on the bottom, new unit on top, and then you can get rid of that unit on the bottom of the next fraction bar if you still need to change to some other unit. And you can do this for as many conversion factors as you need to get to the unit that you're looking for. So in this case, there is 1 minute and 60 seconds. Again, multiplying by the top, dividing by the bottom, I'm going to pick up this new unit of seconds, whereas my minutes gets canceled as I take minutes divided by minutes. The rest of this is just calculator work. So in total, if I don't want to have to do it piece by piece, all in one, I'm essentially taking 6 times 60 divided by 1, which doesn't do anything, times 60 divided by 1, which again doesn't do anything. So I'm essentially taking 6 times 60 times 60. 6 times 60 times 60, and my calculator gets me 21,600. And now my unit is seconds. Not minutes, not hours, not days, but seconds. And if you want, you could put a little comma there. So this is how you convert any two units from one into another. Just make sure that the old unit you're trying to get rid of is canceled out by being divided by itself, which makes way for your new unit. And then just make sure that you have the correct conversion factor that tells you how much of this is in that.